Assalamualaikum and salam sejahtera. We are from Group 3 going to present the visual memory management for the replacement algorithm for OPT and LRU. So let me introduce our team. My name is Adi Natasha.
My name is Ezrali.
My name is Shazina Marsha.
And my name is Afifa Nazni.
Let me introduce the visual memory and also page replacement. So the visual memory is a memory management technique that extends the RAM to fetch the data from the disk to allow larger program to run. So since the RAM has a limited number of frames, it cannot store every page. So the operating system will perform the page replacement to decide which page in the RAM should be removed to make space for a new page. So page replacement will occur in two situations, which is a page fault occur and we need to bring the desired page into the memory, and also when no frame are available. So there are two policy that we are focusing on, which is the least recently used LRU policy and also optimal page replacement OPT policy. So for the LRU policy, it will keep track of how recently data is used. So the keyword is recently. So operating system will remove item that has not been accessed for the longest time and will replace it with a new item. While for the OPT policy, the operating system will replace the page that will not be used for the longest period of time in the future.
Okay, next we will see the real world scenario. So for example, a student is working on assignment while opening multiple applications. The student have opened Google Chrome, Visual Studio Code, Spotify, Microsoft Word and Microsoft Edge. So although modern computers have several gigabytes of RAM, it is still limited. So every application that is running takes a portion of this memory. For example, we can see that the RAM usage is already 88%, meaning most of the physical memory is already occupied. So when another application is open or when an existing application requires more memory, the operating system must free up space in RAM. So it uses the virtual memory management to handle this situation efficiently. So at this point, a page replacement algorithm is required to decide which page should be removed from RAM so that a new required page can be loaded. Next. The operating system moves pages that are not currently needed from the RAM to the secondary storage, such as SSD or hard disk. So this process creates space in RAM for pages that are actively being used by running applications. So as we have seen, our project demonstrates this process using two page algorithms, the LRU and OPT. So next, my team members will show the simulation of these algorithms.
So next, I will demonstrate the least recently used or LRU page replacement algorithm using two examples. So for today's example, I will use 1, 2, 3, 4, 5, 1, 2, 2. So I will set it into 3 frames. So I will click the start button. So page 1, 2, and 3 are loaded into the 3 empty frames. So all 3 requests cause the page fault. So next, page 4 is requested. So since the page 1 was used the longest time ago, so page 1 are replaced by page 4. So next is page 5. Among pages 4, 2, and 3. So page 2 is the least recently used. Therefore, page 2 is replaced by page 5. After that, page 1 is requested. So it is not in memory. So page 3 is now the least recently used. So page 3 is replaced by page 1. So next, page 2 is requested. Page 4 is the least recently used page. So page 4 is replaced by page 2. Finally, page 2 is requested again. So since page 2 is already in the memory, so this is a page hit and no replacement is needed. So for this example, the LRU algorithm produces 7 page faults and 1 page hit.
Now I will be continuing with the OPT algorithm with the default reference string. So as you can see here, we got 3 frames, which is initially empty. So the first 3 reference string will be directly loaded into the empty frames and all will be page 4. So the fourth one, the page 4 will be requested and it will see whether which page to replace is to see that which reference string will be used in the future. So as you can see here, we got 1, 2, and 3 here. And in the future, we still will need to use 1 and 2. So it won't replace the 1 and 2 here. and the number 4 will replace into the frame 3 here. And the next 5 will be requested and it will replace the page that has 4 here too. And the page 1 is requested and will produce the page sheet. The page 2 will also produce a page sheet and also a page sheet. So this reference string with 3 frames will produce 5 page faults and also 3 page sheets. And these are the table that will produce with this OPT algorithm. So that's all for our live website demonstration. Thank you.